I welcome you all to this online tutorial on series of benzene. I'll remind some of you who are new to this channel that this video is suitable for students in Senior 5 and Senior 6 who are offering chemistry as part of their subject combinations. So if you do not fall under those mentioned categories, there are many videos that have been designed to suit your level. So we have looked at what electrophilic substitution reactions mean. Now we explore them in detail. The first reaction is reaction of benzene with the alkenes, reaction with alkenes. So benzene reacts with alkenes in the presence of concentrated phosphoric acid or hydrochloric acid as catalysts to form alkylated benzene. This reaction can as well be referred to as alkylation of benzene. So I give some few examples. So we have benzene plus an alkene, say ethene, in the presence of concentrated phosphoric acid. What shall we obtain? What shall we obtain? What shall we obtain in this case? So concentrated phosphoric acid is serving as a catalyst. So it is going to help us form an electrophile. Recall that benzene, this structure here, undergoes electrophilic substitution reactions. If you look at the illustration which we have seen for electrophilic substitution, it reacts with electrophiles. So this alkene you are seeing here, it is not an electrophile. If you see, there's nothing to show that it is an electron deficient species. So we have to first form an electron deficient species using this alkene and concentrated phosphoric acid. So therefore, for that case, concentrated phosphoric acid will give us a proton. Plus hydrogen phosphate. So concentrated phosphoric acid will give us that proton. Then this alkene, ethene, has a center of high electron density. So we have electrons that can be donated to electron deficient hydrogen. Therefore, we shall have the following. I'll bring my ethene here. Then my electron deficient hydrogen here. Then donate electrons to it using those in the center of high electron density. Markov-Nikov says that this hydrogen goes to the nearest carbon with more hydrogens, but these ones have the same number of hydrogens, so it can go anywhere. Therefore, if I put it here, we shall have CH3, CH2, then with a plus on that carbon atom that has not accepted the hydrogen. So now we have our electrophile. Hope you've seen the purpose of the acid is to provide that proton which combines with the alkene to form the electrophile. Now this electrophile is the one which is going to react with the benzene. So I'll bring my benzene ring here. Like that, and my alkene that has been protonated. So this carbon is electron deficient, and benzene, we have seen that it is electron rich. So we use electrons from one of the double bonds and donate strictly to that carbon that has a plus, strictly, not this first carbon, but the carbon that is electron deficient. Therefore, we shall form the following. We shall have there is a bond there and a bond there. This bond has been broken. It has been broken. And Markov-Nikov says that this now will go to the nearest carbon with more hydrogens. But via the demonstration which I have shown prior, it can go here up or down because they have the same number of hydrogens. So if I put it up here, now it will form a bond with this C, which had a plus, not CH3. You do not put a CH3 because we are donating to CH2. So we have CH2, CH3. Then this carbon here is electron deficient. Since electrons are being taken away, yet it contributed to the bonding. Now I have broken the bond, I have taken its electrons. Then it is electron deficient. I can expose the hydrogen here. There is a hydrogen here. So this hydrogen can donate electrons to the electron deficient carbon. Now once it donates, it also becomes electron deficient. Hope you are seeing that it is lost. So it is lost, or since it is becoming electron deficient, I can bring my hydrogen phosphate ion. I can bring it here. So that, because for it is electron rich, so that it gives electrons to that hydrogen. So we shall form so we have CH2, CH3 plus phosphoric acid. So you see that phosphoric acid is formed back, implying that for it, it was serving a purpose. It did not participate directly in the reaction. Therefore, what is our product? Our product in this case is this. That is our product. That is our product. Ethyl benzene. I'm going to proceed with another example, still on the same reaction. Before, let me write the name here because some Africans may forget that. They can be asked to describe this reaction in words. In words, you do not need the structure. So the name is ethyl benzene. Our second example is here. We have benzene reacting with that alkene. Hope you know the name of that alkene. Its name is, I think it is 2-methylpropene. So we have seen that benzene reacts with electrophiles. And for this reaction, the acid is working as a catalyst. In particular, it will first dissociate phosphoric acid, dissociates to form hydrogen ion and hydrogen phosphate ion. So the aim of these preliminary steps are to form, they are aimed at forming an electrophile. So we have a proton here which is electron deficient, and this alkene is electron rich because it has a center of high electron density. So we can pick electrons from this center of high electron density and donate them to electron deficient hydrogen. Therefore, we shall have our alkene and our proton here. So we donate electrons to that. Markovnikov says that hydrogen goes to the nearest carbon with more hydrogens. So you look at these two carbons. This carbon here is carrying two methyl groups. This is carrying two hydrogen atoms. So it is this that has more hydrogens. So it will go there. So we have CH3 with a 2 there, C, and these are now 3 hydrogens. Then that one will be electron deficient since electrons have been donated to hydrogen. Then in the second step, now we have the electrophile. In the second step, benzene donates electrons to the form the electrophile. So I'll have my benzene, which is electron rich, with CH3 to CH3. So we have a center of high electron density that can donate electrons to specifically that carbon with a plus. So once it donates, we shall have the following. We have our ring, a bond there, and a bond there. So this has been broken. So this carbon can be attached to that carbon or to that carbon for reasons which I've given in the previous example. So it can come here, see, that carbon carries two methyl groups. Are you seeing these are two methyl groups? Then this is the third. It carries 3 methyl groups. So I'll write them as CH3 and put a 3 there. Then put a plus on that carbon since it is electron deficient. Then there is a silent hydrogen there. So we can donate electrons and lose this hydrogen as a way of stabilizing that carbon. So since it is electron deficient, we have taken electrons and donated them to this carbon. We can bring the hydrogen phosphate. Hydrogen phosphate is electron rich. It donates to hydrogen. Therefore, we shall have the following. We shall have this as our product. That is our product. So I put the product. Do not forget always to complete the reaction mechanism and the equation. Complete the equation as well. So that is our product. Now the question is, how can we name that product? Look at it carefully. It has, I want to derive its name. It has a carbon. I'll start with the carbon. This carbon here. This carbon is carrying 3 methyl groups. It's carrying 3 methyl groups. I'll put a methyl group there up, another one there, and another one there. Those are the 3 methyl groups. Then it also has a benzene ring, the carbon. That is the benzene ring. Now the question is, what is its name? This is 1, 2, 3. 1, 2, 3. If you still remember the nomenclature rules, so I assign positions to the carbon in the parent chain, to the carbon atoms in the parent chain. 1, 2, 3. Also 1, 2, 3. So you see that at 2 there are 2 branches appending from the parent chain. There is this and that one. And how do we call this branch? Recall that Benzene as a branch is called phenyl. As a branch, it's called phenyl, and that is methyl. So methyl and phenyl, I think M comes first. I don't know. What comes first? HIJKL, I think M comes first. So we shall call this 2-methyl 2-phenyl propane. That is its name.